Okay, so we're going to look at, in this video, we're going to check out vertex form of a quadratic function. So this is a form of a quadratic that we haven't seen yet. So we're looking at specific polynomials now. Polynomials that are degree 2 only. So we're used to like seeing it in this form, which would be standard form, or seeing it in factored form. Whoops, I should write y equals. Or factored form. Ax minus whatever number, and then x minus whatever number. And since it's a quadratic, there'd only be 2 of them there. So this is standard form, this is factored form, and now we're going to look at another one called vertex form. I just want to remind you, like over here on Desmos, if I make a quadratic, and I'll put it in standard form, right? So there's some quadratic I made up. Since we're looking just at quadratics now, there's some key features we want to look at. One of those is the vertex, right? That's kind of the main point. We've got a vertex here. It's going to be right at the bottom, or if my parabola opens downward, it'll be right at the top. It's either that maximum or minimum point. We're calling that the vertex, okay? Another thing that we're going to look at, I want to go to that one that opens upwards. Another thing we're going to look at is that a parabola has symmetry. So there's something called the axis of symmetry. So this would go, I'm going to draw one on here. It'll split the parabola in half. We usually write it as a dashed line. So there's symmetry. And the vertex will go right through that line. The axis of symmetry goes right through the vertex. Then you have all these other points that have symmetry, like those 2 x-intercepts. They're equidistant from the axis of symmetry. This point here will have another sister point kind of like over here, right? Every point has a symmetrical sister point, I'll call it. All right, so what we know. In standard form already, right? I already wrote that one down, but we'll write it out again. Y equals ax squared plus bx plus c. We also know a factored form. We'll say it's y equals a times x minus some number, I'll just call it p, and then x minus another number, we'll call it q. All right, so our new form is going to be vertex form, and this is the form it's going to be in. And this form is going to kind of make sense because of the work we did with transformations before. That's going to be the format, right? So we're going to have to put numbers in for a, for h, and for k. Something to note in this formula, the h has a negative sign in front of it, right? There's a negative in front of that h. The k has a positive in front of it. So that just kind of means that for the h, it's going to be the opposite, and for k, it's going to be the same. Yeah, can I help you? You're coming in at 3, right?
Whenever you tell us.
Yeah. Okay. Yeah, I'll be done in like 5 minutes. Okay. So what it tells me is the h is the x value in the vertex, and the k is the y value in the vertex. So this one over here, I would know that the h in there would be the 0.75, and the k would be the negative 6.125. All right, but don't write those down. I'm just showing you that that's the vertex. So hk is the vertex, and we're going to pull it out from this equation. The h comes from there, the k comes from there. We'll put arrows going both ways. So we're going to know the coordinates of the vertex. That's why it's called vertex form, and that's why it's important. Okay? We're also going to know the axis of symmetry. That's that line that shows the symmetry of the parabola, right down the center of it. That's always going to, it's an equation of a line, and it's a vertical line, so it's always going to be x equals whatever the number h was, okay? And that's going to be the x value of the vertex, because that line will pass through the vertex. So the h that you see here is the same h that is the x value on the vertex. So this h will be the same number here, which all comes from here, okay? So we're going to have a look at some examples now. All right, so here's an equation of a parabola. Now, first of all, a quadratic. I know it's quadratic because the power is 2. I forget I can use my laser pointer. right? This exponent here, squared, that tells me it's quadratic. The a in front, by the way, up here, this a is the same a that we always use. When a is positive, the parabola opens up. When a is negative, it opens down. So here, the a is like a 1, all right? But we've got these two pieces of information here. So if I pull down that h value, when I write it as a point, it's going to be the opposite, okay? And that's because, remember, like when we were shifting and reflecting graphs from transformations, if you were inside with the x, it was like the opposite. So we know that the x in here is the opposite, and the y, the stuff on the outside, is actually -6, okay? Now, technically, that still is the opposite because the y should be written on the left side with the y. Technically, we should probably think about it like this. How would I bring -6 to the other side? I would add 6 to both sides, and I'd get this new equation. When you think of it like that, you can see that it's the opposite for both, okay? So that's probably the way that we should think about it. Our axis of symmetry is always, always, always going to be x equals, and it's the same x that was the x value of the vertex. So let's take a look at this one over here. Let's type it out. Y equals quantity x plus 5 squared minus 6. And we're going to type in our axis of symmetry. X equals -5. See, it makes that vertical line that cuts the parabola right down the middle and goes through the vertex, which has coordinates -5, -6. So I want to give you a picture, a graph to back up what's happening here with the equations. All right, let's try B here. So here's another one in vertex form. Keep in mind that this is the A, and since it's positive, I know the parabola is opening upward. All right, the squared here is telling me that it's a quadratic, making it a parabola. Here's my H, here's my K. I'm going to say that I like to rewrite it like this. I'm going to add 7 to both sides of the equal sign. Right, so now I know that the vertex is really both the opposite signs. So the x-coordinate of the vertex I get from here. So I'm going to plug in 3. And the y-coordinate I get from here, I'm plugging in -7. So there's my vertex. It's at 3, -7. And my axis of symmetry is at x equals 3. Because I always use that same x value. Let's graph that one over here. So we have y equals 2 times the quantity x minus 3. And then it was -7. And my axis of symmetry now would be x equals 3. Now check this out. The -7, look over here on Desmos. I'm going to place it over here. I'm going to write it on the other side. If I add 7 to both sides, on this side the -7 goes away. You see it's the same parabola. So I like to think of it like that because then I know it's the opposite for the x and the opposite for the y. All right? Now we're going to work on writing an equation from some given information. Write the equation of the quadratic function with a vertex of -3, 2 and a leading coefficient of 2. So the leading coefficient of 2, that means that our a is 2. Excuse me, and if they give me the vertex, I have my h, I have my k, so that means I'm going to use vertex form, because if they give me the vertex, vertex form is the best. I recommend that you write out the vertex form with nothing plugged in, right? So then that means we're going to want to put in a number for A, we're going to want to put in a number for H, and we're going to want to put in a number for K. And that's why there's a minus in the formula for the H, because it takes care of the opposite thing. You'll see what I mean in a second, this minus here. So what am I going to plug in? Well, my H was -3, so I'm going to go fill in a -3 here. My K was 2, right? My K over here is 2, so I'm going to fill in a 2 here for K. And then my leading coefficient, excuse me, is 2. So that's my A. So I'm going to put the 2 there. And there it is. Excuse me. So now I'm just gonna rewrite it and get rid of this double negative sign here, call it x plus 3. And that's what students start to remember, that, hey, the inside with the x is the opposite, and when you put the outside one, it's the same, right? Because what we mean by that is the h was negative 3, but in the equation, it shows up as x plus 3. The k was positive 2, in the equation, it shows up as positive 2. So keep in mind, it really was the opposite. If you do it my way, you really should write it as, since it's a 2 in here, you should really write it as y minus 2 equals. Right, I should write the y on that side, and then we want to solve for y, so we add 2 to both sides. On this side, they cancel, and I get x plus 3 squared plus 2. All right, but either way you remember it, you want to get to that final answer. For number 3, write the equation of a quadratic function with a vertex of negative 1, 4, passing through the point 1, 8. So again, since we're given the vertex, that's our h and that's our k, we're going to use vertex form, y equals a times x minus h squared plus k. I like to write it out. So remember, I'm going to fill in a number for a, I want to fill in a number for h, and I want to fill in a number for k. So my h is negative 1, so now I'll switch over to purple. I plug in a negative 1 for h, I get that from right here. The x value of my vertex goes inside with the x coordinate here. The y value would go over here with the y, so it would be y minus 4, but then I would add 4 to both sides to bring it over here. And then my a, oh darn, they don't tell me my a here, right? They just give me another random point. They don't tell me the a. So I don't know what a is, so I have to leave it as a for now. So now I'm just going to rewrite this. Y equals a times x plus 1, because this double negative becomes plus, squared plus 4. How do I find a then? Just like we found it before, they just give us another point. This is an xy pair. So I know x is 1 and y is 8. So to find a, I'm going to temporarily plug in my x and my y. So y was 8, x was 1. So I'm going to get 8 equals a times 1 plus 1 is 2. Now I'm going to get 8 equals, I'm going to square that 2. I'm going to write it like this, 4a. I'm going to this is a times 4, I'm going to write it as 4a. It just makes more sense to me. Now I got to subtract 4, a lot of 4's going on here. Subtract 4 from both sides. Whoops. 8 minus 4 is 4. Then I have 4a, and then these cancel. Then I'm going to divide by 4 on both sides. And I get these cancel, and I get a equals 1. So now that I know a equals 1, I can come back up here and replace my a with 1. Okay, and that will be the equation in vertex form.